So first let's read the problem statement, then we will think of an approach and implement it. Okay, so the today's problem is the count odd numbers in an interval range. So we are given an interval range, inclusive interval range, from low to high, both are inclusive, and we have to count the total number of odd numbers in it. Okay, and the constraints of the problem are pretty high. That means that uh, the low and high can vary from 0 to 10 to the power 9, which means that a brute force approach in which we will just iterate from low to high and return the odd numbers won't work because it will leave us time limit exceeded. Okay, so we would have to think of a better approach. So how can we think of a better approach? So simple thing I can think of is first think of this 3 to 7. These are 3, 5 and 7, and from 8 to 10 it's 9 only. So first let's think of an approach. How will we tackle this problem? Just like, for example, we are given from 3 to 7. Okay, and one observation is that from when we are iterating over a range, our odd number gets in an interval of 2, just means 3, then 5, then 7. Okay, that means that suppose we are given a range, then only the about a half of it would be our answer, but there would be different cases possible here. It's like the less one would be odd and the greater one will be odd, and lower one will be 3 and greater one will be 3 odd. In this case the answer would be different, and if one of them is even, in that case answer would be different. So how can we make observations regarding that? We can make cases and conclude and return the answer in big of one complexity. Okay, so now let's form the cases. So there are different cases possible, just like if our first number is the simplest case is that if we are given two equal numbers, lower is equal to higher, and both of them are even, then in that case our total number of numbers in the range is 1. 2 minus 2 0 plus 1 is 1. 1 is the total number, and in that case answer will be 1 divided by 2, that is 0. But if the similarly 3 and 3 is given, in that case the total number is also 1. Okay, but in that case we will take the ceiling of this number. That means that if the total number is 1, we will do it to 2, and we will do 2 by divided 2, and answer will be 1, the 3 only. Similarly, now let's take a case in which the first one is even and second one is even but not equal, that is 2 to 8. In that case we will do similar, 8 minus 2 plus 1, total number is 8 minus 2 6 plus 1 7. There are total 7 numbers, and out of them uh, our answer will be 7 by divided by 2 is equal to 3. Okay, how it will be 3? It will be 3, 5 and 7 only. So this is the observation we made. Okay, and if the second one is odd, how do we do? 9 minus 2 plus 1, and in this case total numbers are 9 minus 2 and 7 plus 8, and in that case the answer would be simply 8 divided by 2, that is 4. So how are 4 numbers present? 3, 5, 7, 9. Okay, and what if both of them are odd, that is just like both of them are just like 1 and 9? In that case we would have to make a separate condition for the first one. That's why we are taking the ceiling in the case if the both are odd. In this case there are 10 total numbers possible, 9 total number possible, and our answer would be 9 plus 1 divided by 2, that is 5. Got it? We are taking a ceiling with respect to 2 if both of them are odd, and if the first one is odd and second one is even, in that case we simply count the total number in the range, and this is 8 minus 3 plus 1 plus 5 6, and in that case our answer would be simply 6 divided by 2, and which is 3. uh, 3 odd numbers are possible are 3, 5 and 7. Okay, so this is our answer. So basically our result is that Suppose our result is that even if one of them is odd, one of them of between lower and higher is odd, in that case we would just simply calculate the total number in the range, that is h minus l plus 1 divided by 2, that would be the answer. If both of them, if even one of them is not odd, okay, and if both of them are odd, in that case we would have to take the ceiling, okay. In this case both are odd, both odd. In this case we have to take a ceiling with respect to 1, that is h minus l plus 1 plus 1 divided by 2. So this is our simply answer, which will give us answer in big of one time complexity. So now let's implement it. Okay, and if if both low and high are odd, then we would return high minus low plus 2 divided by 2. Otherwise we would return high minus low plus 1 divided by 2. So let's check for it if it's working or not. Okay, now let's try to submit this. Let's see if it's working or not. Okay, so this is perfectly working. So today, this is today's Leetcode LHN problem. Thank you.